unfortunately, my Spanish doesn't go very farther than that. But it is an honor to be here with you today here in Bogota for our first Public Sector Summit. I'm going to be talking to you about security in the cloud, and I'm going to be sharing with you my personal journey from a traditional cybersecurity professional into the cloud, and kind of interweave in some of the concepts at a higher level for what the security objectives you should be looking for in the cloud. So with that, a little bit of background about myself. I was in the U.S. Navy for 25 years. I was the Navy CIO for Japan, the Navy Regional CISO, or Chief Information Security Officer for Asia. And in my time in the Navy, I never really had experience with cloud from a professional perspective. I managed the data centers in Europe and the networks in Europe, as well as in some of the aspects in Asia that I just discussed. I was just so used to just managing your typical data center network, right, from that legacy perspective, securing it with your traditional security technologies. When I left the Navy a few years ago, I went to the city of Washington, D.C. In the city of Washington, D.C., I was the Deputy Chief Information Security Officer with a strategic focus on governance, risk, and compliance. In that role, the city was starting to adopt the cloud. From my perspective, I was absolutely terrified of the cloud. I was worried about I was going to lose visibility of my data. I was going to lose the compliance. How can I make sure I maintain compliance for all the different regimes that I had responsibility for? And so I tasked my team and myself to start learning about the cloud. I didn't really feel like going to get a new job right away after I just left the Navy. So I decided to try to learn about the cloud, try to figure out how we can meet our security objectives in the cloud. I tasked my team to figure out how we can do the same job the same way in the cloud. That was a terrible task because I handcuffed my staff by saying doing things the same way. All right, so when you're starting to look at emerging technologies and different concepts, you have to be open to doing things differently. You have to be open to learning at new opportunities of how you can improve your services. So it didn't take long, though, for us to figure out that, yes, we could achieve the same security objectives doing things the same way in the cloud. All right, we can spin up our virtual servers, we can configure them, we can patch them, we can run scans against them, we can implement firewall rules. We could do a lot of the same things on-prem in the cloud with the same types of concepts. All right. But as we started to learn, we started seeing new opportunities. We started seeing benefits that we really weren't expecting. And those benefits really resulted in the fact that we had challenges in an on-prem environment that we had just come to accept over the years. Right? Sometimes technology or some of the things that you're trying to do, sometimes they're just too hard. Right? And so you get to the point where you just kind of accept things the way they are, and you move forward and do the best thing you can. However, the cloud highlighted 4 challenges in an on-prem environment that had been kind of holding us back for a very long time. The first was visibility. The second was resiliency. The third was finally being able to achieve that defense in depth that we've been talking about for decades. And the fourth was automation. I'm going to go into each of these and how through our learning experience we found these to be benefits of the cloud. All right? Which then improved our security and compliance posture. Starting with visibility. It's a little counterintuitive to think that when you physically own your data centers and you physically own your server racks and the servers, that somehow you don't have perfect visibility. All right? But especially in today's virtualized environment, that's very difficult to achieve. All right? So before, when you had 10 physical servers in a rack, you knew you were supposed to have 10 servers on the network. It's easier to maintain, manage, and control secure. Now those 10 physical servers could each have 10 virtual servers on them for a total of 100 servers on the network. But how many should be on the network? Have you maximized your virtualized environment so there's now 100 servers on the network? Or should it be 87 or 42? It's very difficult to really know how many servers should be on the network. In addition, oftentimes in many organizations, you have servers, physical servers, still in a data closet somewhere. or under somebody's desk, right? Or segmented off onto some network where the security tools could no longer see them, right? So it's very difficult to maintain that visibility in a logical environment. In one of the organizations I worked for, we actually had 2 virtualization environments. One was Hyper-V and one was VMware. So if I wanted an accurate inventory of all my servers, I had to try to add both of those inventories together and then try to make sure I understood where all the physical servers were at throughout the organization, throughout the data closets, under people's desks. Very tedious and very inaccurate. All right, so when you look at the CIS top 20 controls, controls 1 and 2 are inventory of your hardware, inventory of your software. If you look at a lot of the challenges today in cybersecurity, a lot of them stem back into the fact that we don't always have the perfect visibility that we really need. Right? So that's when systems are not really patched because they're not being monitored, or we don't even know that they're there. I don't know about you, but I've had experience where every 6 months or so, some server would pop up that we lost visibility of that has some old operating system on, or hadn't been patched, or we've lost the sysadmin credentials to it. Right? And it really goes back to that lack of visibility. What we realized in the cloud is that for the first time, we were finally able to achieve full visibility. It no longer mattered if a server was turned on or off. It didn't matter what network segment it was on, or whether the endpoint protection was reporting up properly or not. We were finally able to see everything within our environment, which kind of caught us off guard. We really weren't expecting to kind of go back and realize that we had this deficiency before. We've kind of forgotten that we accepted that deficiency over the years. So I'm going to talk about, first, the means of which you can obtain visibility in AWS. The first is through the console, a web console. You can log in, you can take a look at all your servers, all your resources, everything that you're using within AWS within your account. This is a rather manual process, so I wouldn't necessarily recommend it for optimizing your operations, but you can use that and gain access. The second thing is you can now tag all of your resources. You tag all your servers, your services, your data. So if you have a compliance framework to meet, such as maybe PCI, you can tag all the resources and data that are related to PCI, so that you can then monitor that and make sure that they're being secured properly and you can maintain that compliance. You have your command line interface queries. So your developers can query the data, query information about the resources that they're using within AWS. But the key is APIs. The use of API is the only way that you're going to be able to scale your operations for security and automate your operations for security, right? So through APIs, you can bring in all your security logs, all your security information to partner products such as Splunk, or your on-prem SIEM, all right? Or the business intelligence tools. Now this one highlights your spending, but you can actually use it to highlight and track some of the security functionality or compliance structure within your architecture, okay? So the key here with the cloud for security is API. This is a means of obtaining visibility. Next, I'm going to go over a couple of security services that help you track everything within your environment. Okay. The first is CloudTrail. Every action within AWS is through an API. So even when you click on the console, a link, it gets converted into an API. So all of the actions track who made the command, when they did it, what services they were interacting with, and what were the commands, okay? What's different from how you normally see this in an on-prem environment, in an on-prem, you have various different technical platforms that are all doing their own logging. So you have your routers, your firewalls, your Windows servers, your Linux servers, and everything else. All the logs are different. All the schemas for those logs are different. Now, you're probably bringing them into some type of log aggregator or your SIEM. But because they're all different formats, you have to do some form of transformation on that data so you can actually correlate the activity across all of them. But what happens if the endpoint isn't reporting properly, or the log aggregator isn't functioning, or it's off of some network segment that's not allowing that communication to happen? You're not necessarily getting all of the logs, okay? With CloudTrail, the key here is that within the cloud, you have this homogeneous environment. This environment, this underlying environment, is all structured the same, can all communicate. So what you do on the top within your environment, when you're interacting with those APIs, you're not losing any of those logging services or any of that logging data from the underlying infrastructure. All right, so now you're starting to see a little bit of an improvement of really a function that you do today in on-prem, which is basic logging. Next is Amazon VPC flow logs. Your VPC is your virtual private cloud or your security boundary around your application. The flow logs are all the network traffic going in and out of your VPC. Right? So not much difference in what you have right now for your on-prem environment. Right? You're tracking all the network activity coming in and out of your environment. Next is CloudWatch. CloudWatch brings all of the logs together from CloudTrail and the VPC flow log, and it can create events and alerts for you. So I hate to say it's like a SIEM because it's not necessarily as powerful as an on-prem SIEM, but it has some of that initial basic capability. Fourth, we have our web application firewall. So you can create your rules, allow certain communications into your environment for your web servers, deny, but it gives you that visibility in what is being allowed in and what's being denied. All right? And then fifth, right here, we have Amazon Inspector. This is a vulnerability scanning service similar to Nessus and Nexpose. So you can scan your servers looking for those vulnerabilities. An added feature, though, for Inspector is that even without an agent installed, we have a feature now that will let you know if a particular server is accessible from the public internet. So in your on-prem environment, if you go with, say, a standard 3-tier web application, so you have your web server, which should be open to the public internet, an app server, which should not be, and a database server, which should not be open to the public internet. If somebody misconfigures the firewall or your perimeter security, how do you know that somebody can actually get to your database server from the internet? Right? That could be a challenge. The feature with Inspector can tell you this right immediately, whether or not a server is accessible to the public internet. If somewhere somebody made a mistake in the configuration. All right? So these 5 services are very similar to the services you have in an on-prem environment, just using AWS capabilities. What starts changing, though, again, using that homogeneous environment, is we have services like Trusted Advisor, where it looks for best practices for security, cost, and performance. So one security best practice is the use of multi-factor authentication for your root accounts. If you have not enabled that, it'll let you know that you're not following that best practice. All right? Also, it looks for opportunities for you to improve performance. So if you're running a machine learning application on your general compute instance and it's taking 2 weeks, say it's for something like genomics, it will recognize that type of work and make the recommendation. If you move from a general compute instance to a GPU or graphics processor unit, or graphics processor, you can change to maybe reduce it from 2 weeks to 2 days, okay, for performance. And likewise, one of the early challenges for customers is they have these large servers that are built to hit some type of peak performance, okay? When you move to the cloud, you don't necessarily have to have that one single large server because you have the ability to scale out and scale back in. So, but if you move into that large server, it'll see that the standard utilization of that server is, say, 30%, 40%, and it will give you recommendations to reduce to a smaller compute instance and actually save money every month, okay? So all of this is automated. It's not somebody at AWS looking at your environment. This is just the environment knowing about itself and being able to let you know when you're not necessarily following best practices. Moving over to Amazon Macie, this is similar. This has 2 capabilities. One is similar to a data loss prevention or DLP service. DLP typically sits at your perimeter and is looking for sensitive data that's trying to leave your network, right? And it either blocks it or it'll let it go and send an alert. Macie looks at all your storage, all your files within S3. S3 is our simple storage service, which is a block or object storage. It will look at all of your files and objects in that storage, and it will let you know where your sensitive data is at before it's ever accessed, before it ever tries to leave your environment. So it will look things for like credit card numbers, encryption keys, and such, okay? It also has the ability to implement rules. So if you have a rule that says all credit card numbers must be encrypted, and it finds an Excel file with credit card numbers not encrypted, it will go back and it'll encrypt that file or the whole bucket depending on the rules that you've generated, okay? The second capability of Macie is it has some limited user behavior analytics, right? Over time, it learns the files that are accessed, who accesses them, and how often. So if you do have that Excel file that has credit card numbers in it, and there's typically only 2 people in the office that access that file, and it's usually Monday through Friday, normal working hours, it learns that. If that file starts getting accessed at 2 o'clock on a Saturday morning by somebody else, or say 500 times, it's going to alert on that. So it learns that normal behavior for accessing that sensitive data, and it will alert you when it sees an anomaly, okay? The AWS Artifact is not necessarily what I would consider an actual IT service. It's just a repository of all of our third-party audit reports, okay? This is where you can go and look to see and validate that we are doing what we say we do. So all of our SOC reports, our PCI reports, FedRAMP for the U.S. government, ISO, all of the audit reports that are generated from our third party, they are stored in there, okay? So if you want to look at specific controls that we have implemented, you can look at our SOC 2 report that lists all those controls, okay? So now you have proof from a third party that we are doing what we say we do, right? These are the controls that you're going to be able to inherit within your environment so that you can achieve compliance if you need to meet that same compliance. The last one on the screen is Amazon GuardDuty, which I'm not going to go into much detail just now, but you're going to see it throughout this presentation. It is our intelligent threat detection service, all right? So it's constantly looking at your environment, identifying threats, and alerting you to those threats. So all of these services are giving you added security visibility into your environment. Moving into resiliency. Resiliency, for me, was always a challenge, right? So when we look at the CIA triad, confidentiality, integrity, and availability, we focus a lot of our effort on the first two. Availability is extremely expensive and difficult to achieve, right? In my experience, even the most critical applications, even those for safety services for a city, only lived in one data center. And oftentimes, they only lived on one or a couple servers in a stack. So if we lost the entire data center, we lost a critical service to the city, okay? Or if we lost one server in that stack, we lost the services to the city, all right? So if you're here in Columbia, you have 1, 2, 3 for emergency services, correct? So imagine if the system that supports that is on a couple servers or in one data center and something happens and that service is now down, right? So that could be a big problem. And so we experienced that in the States. The challenge here is that it's very difficult and expensive to load balance a single application across multiple data centers, okay? And so this is where AWS can help you with improving your resiliency on a couple factors. To start with this, I'm going to go over the AWS infrastructure and how our infrastructure is built so that you can build your application on top of ours. So first, we have 20 regions, 60 availability zones, and 149 edge locations. And I think if you heard this morning, we just announced another edge location coming here to Bogota, Colombia. So I need to change that to 150 now. All the circles and the numbers in the circles and numbers in parentheses are the number of availability zones in each region. All right? The edge locations are not depicted on the map. All right, so what is a region? Even though there are multiple cloud service providers and we all use the term a region, what is comprised of region for each of us is a little bit different. Okay, so this is something that's very, very important to understand when you're talking to a cloud service provider. Because if the cloud service provider does not have a high available infrastructure, you're not going to be able to achieve high availability on your applications or workloads. Okay, so within AWS, a region is a metropolitan area that's semi-isolated from the other areas. Okay? Within a region, it is comprised of 2 or more availability zones. The new standard is 3 availability zones. So there's, from here on out, there's always going to be 3 availability zones in new regions. Okay? An availability zone is a fault isolation zone. It is not something physical. It's a concept. It's how we organize and architect our infrastructure. What this does is that this allows us to do maintenance in certain areas without affecting the entire region. It allows us to limit any service impact to an outage so it doesn't affect the entire region. Okay? For you, when you use more than one availability zone, it allows you to do maintenance on your application in one availability zone without affecting your overall application. Okay? An availability zone is comprised of 1 or more data centers. Typically, there are more than one data center. Our data centers are physically separate facilities. This is also something to ask when you're talking to cloud service providers, because even if they have more than one data center, they're not necessarily always separate buildings. They could be on separate floors of the same building, okay? Or it might only be one data center for the region. So this is something to really ask and understand. Our data centers are built on low-risk floodplains. We have multiple internet connectivity from different providers, multiple power from different providers, and of course your typical physical security, water, gas, fuel, backups, and so forth, okay? So this is our infrastructure. But what does it mean for you? Uh-oh, looks like some of my... Let's go over to this one, please. All right, so say this is an application that you have now. This is your data center. The firewall just represents your total perimeter security, okay? You have a load balancer that is maybe 1 or 2 physical devices. You have some web servers, an app server or 2, and some database servers. In this environment, if you lose your data center, you've lost everything. If you've lost your perimeter security, you've lost everything. If the load balancer, if you only have 1, you've lost. If you have 2, unless you bought 2 really robust load balancers that can handle the full load, you've probably started reducing some of the capacity. So maybe some of your customers are not able to get to the servers. If you start moving down the stack, if there's 2 app servers here and you lose 1, again, you lost half the capacity for your application. And not only that, but chances are the customers that were starting to go down that path are now getting a lot of error messages. Okay, so now you got some angry customers. When you move to AWS, you're going to start with the region. You're going to pick the region that you want to go into. One thing I should have mentioned on the earlier slide is that when you put your data into an AWS region, it stays in that region. We do not copy, move, or back up your data into any other region for any reason. Okay? You have full control and ownership of your data at all times. So you're going to pick the region you want. Then you're going to create your VPC, your virtual private cloud, the security boundary around your application. You're going to select at least 2 availability zones, although I recommend at least 3. You're going to add your subnets. So this is where things start changing. Now you're going to have this elastic load balancing service. All right, so this is a service. This is not a single device that if it fails, your application is going to go down. All right, so this service is going to provide that load balancing to the top. In addition, you can now add load balancing services in between all the tiers on your app. Okay, so now you add your servers. In this particular case here, if this app server over here dies, the load balancer here will detect the failure in health and automatically shift everything over to the other side. Okay? Now remember, these 2 availability zones are in 2 physically separate data centers. Okay? The next thing you're going to do is you're going to add an auto-scaling group. This is one of the greatest advantages of the cloud, is being able to scale out and scale back in. So if you pretend that you're a university and you have a course registration application where most of the year it's not really being used. You may have some administrative staff that's updating the content, updating the dates of the next semester, but it's used very minimally. Right? Then, 3 times a year for the next semester, you open up the course registration application, and thousands of students hit it trying to register for class. So in this environment for on-prem, you're buying a very large, expensive servers to handle that peak performance that only occurs 3 times a year. That means the most of the year, the money that you put in that is being wasted. You're not getting full value for what you bought, okay? So what changes now is instead of having that really large set of servers, you go to really small servers, okay? Very, very, just something to handle that daily usage, okay? And you split them. And because of the fact that you're not using that very large server, this architecture right here, where you start getting that high availability, actually costs less, right, than buying those very large expensive servers. Even as you have twice as many servers now, they're much smaller, okay? So the auto-scaling group now allows you, so you have these small servers. As soon as you open up the course registration application, it sees that utilization. Are we matching now? Okay, I think we're matching now. They see the resource utilization, and what'll happen is you'll start spinning up. Wait, it's still not working. All right, you start spinning up these other servers, right? And it starts taking on the extra load, right? So now you're only paying for those extra servers when they're online during that registration season, okay? As soon as the registration season is over, then you take down the servers, spin down, and you're not paying for them anymore, all right? So now this is something you can budget for as well. So if you know those 3 months of the years when you have to pay a little bit extra for course registration, you're going to have additional servers, you can budget for that more, right? Now sometimes this is something that's not a monthly occurrence or multi occurrence. Maybe this is something where the application is really only being used during the day, and then at nighttime, because everybody's home, the application goes down, right? It's not used anymore. And so then you can spin down a lot of your servers and actually save money at night. Or like in the old days of bank transactions, batch transaction, right? If all the batch occurs at night, they spin up at night, do the batch processing, and then they shut down, okay? So this is where you're starting to save some money by being able to auto-scale out. Okay, I'm just going to stick to this one. Another thing, this allows you to stop treating your servers like pets, right? So right now, if you've ever been a sysadmin or you know sysadmins, they treat their servers like pets. They give them names, they feed them, they pet them. If the server dies, they cry. It's a bad day, right? Because they know they're going to spend hours or days getting that server back up and running, okay? In this model, we don't care. If this server dies, if it just fails for some reason, the environment will detect that failure of health and automatically spin up a new server to replace it. Meanwhile, the load balancing is sending everything over to the other side. So your application stays up, your customers stay up. Nobody really knows or even notices the impact, okay? So we have one customer you might have heard of. They're called Netflix. They have a service that they developed called Chaos Monkey that specifically goes through their environment and starts shutting down servers. They test their high availability every single day. I guarantee you, if you're a Netflix customer and you've been watching a movie or a TV show, while you were watching it, at some point, whatever was servicing that movie, that content, was cut, was killed, and something else took up and replaced it, and you never even knew. All right? So that's kind of the extreme of what you can achieve with high availability in AWS. And then you can also move to managed database services. Got to love it from a technology provider, right? You can move to managed database services where we manage that infrastructure for you. We manage that configuration for you. All right. So now you can see how you can achieve high availability on AWS because we have our high availability infrastructure. All right, so moving into defense in depth. Right, so this is a concept that we've been talking about for decades. People now, when they hear it, they kind of cringe. They don't like it, right? Because the reality was we never really achieved defense in depth. This is the reality. Right? We have a hard perimeter, hard outer shell. Everything inside is soft and gooey. And a lot of in my personal experience and a lot of customers, if you walk into a data center, everything in the data center can talk to everything else in the data center, even if there's no reason to. Right? So this is why we're seeing the new threats. attackers aren't necessarily trying to go into the front door anymore because we've gotten really good at that outer shell, securing that outer shell, right? But they know everything inside is open. There's an open trust model. So what do? They send in phishing emails. Somebody clicks on a phishing email because that person is inside the network and everything inside the network is trusted. They can now move about the network and get to pretty much anywhere they need to get to, right? So this is the reality of today. So I'm going to walk through a little bit about how you can achieve defense in depth. I'm going to start at the perimeter, which will be somewhat similar to what you're used to. You have your ACLs, your access control lists, for a stateless firewall type capability. I'm going to back up. By default, your VPC has no public internet connectivity. So whatever you put in your VPC by default cannot be accessed by the public internet. Okay? So for you to access the content in it, you can either log into the web console, all right, or you can create a private fiber connection through AWS Direct Connect, so you can extend your on-prem network into your VPC, so you can manage it. You can add a VPN gateway, and if you do need to have it open up to the public internet, you can add an internet gateway, all right? By default, everybody has Ddos Protection for free through AWS Shield. So right, this is probably something you're having to pay for extra now. We have our Web Application Firewall. We have one of the largest ecosystems of partner products. So if you're using an F5 or Checkpoint or Palo Alto now in your on-prem environment, you can use that same capability inside of AWS, okay? And then Amazon Guard Duty. Again, I'm not going to talk about that just yet, but you'll see it in the overall environment. So while I swapped out some of the AWS service names, you should see that this is probably similar to what you have in an on-prem environment. What starts changing, though, is now you have a security boundary around each of your applications, where before your security boundary was the overall network. By default, there are no communications between the two VPCs, even if you own both VPCs, okay? Now, if you need to, you can add an internet gateway and allow communications at the application layer between them. You can use private link for one-way communications if you're using microservices, or you can add a VPC peering to actually establish a network connectivity between your two VPCs. Right? So you can add that connectivity if you need different applications to communicate to each other, but by default, you have security between your applications now. Okay? And then this is where you really get into it. So we still have the ACLs, but now we're going to add security groups around each tier of your application. A security group is essentially a stateful firewall capability. Okay? So typically, even if you did have some type of network segmentation or some type of security between applications, we rarely see security between the tiers of an application. So now you're able to get this stateless firewall capability around each tier of the application, right? Because a web server should never be talking directly to a database server. If that's happening, the web server is compromised or going straight after the data, okay? In addition, as you start spinning up more servers for scaling out, by default, the servers inside of a tier, inside of a security group, cannot communicate with each other. Again, there's no reason for one web server to talk to another web server, right? That's not the application flow. It's from web server to app server to database server and back up, right? So now you have security between the tiers and within the tier of your application. You can still install whatever third-party endpoint protection software that you want on your virtual servers or EC2 instances. I talked about Amazon Inspector for scanning your servers. Systems Manager helps you manage your fleet of servers, Linux or Windows. It pushes patches, it keeps inventory of your assets. I already talked about CloudTrail for logging all the activity in your event, CloudWatch for bringing all that together, and there's that guard duty again that keeps popping up. All right? But this is how you are able to move from security at just the perimeter, right, and maybe an endpoint protection, maybe some network segmentation, to where you're really starting to get security throughout your entire infrastructure. This is really closer to the true defense in depth model that we've been talking about for so long that it was almost impossible to achieve, right? Because we couldn't really afford to put firewalls in between all of our applications inside a data center, right? At some point in time, we had to get to the point where just because of cost or resource availability, we had to have some level of trust, right? This allows you to start moving from an open trust model to a zero trust model, right? And so if something does get compromised, it stays within a particular area and it doesn't move around. All right, so last security objective, automation. This is the most important when you're looking at being able to scale your security, all right, and improve the efficiency of your security operations, all right? Even if with the best SOC analyst or security operations center analyst that you have, people just cannot respond fast enough to cyber events, okay? So automation is going to be key. And to start with that is really going in with the concept, remove humans from the data, all right? While there are, news articles about people doing bad things on purpose, the reality is the most of the time, people either just make mistakes, and or they're just slow to react, okay? They have good intentions, it just happens, all right? So for us, we start with Amazon GuardDuty. So GuardDuty is our intelligent threat detection service. It brings in threat intel feeds from Proofpoint and CrowdStrike. Okay. Also threat intel from what we pull together from managing our global infrastructure. Everything in white is threats that are based off of signature or stateless threats. Everything in blue are behavioral or stateful threats that GuardDuty can detect. So when you look at some of these from the, let's see here, the brute force attacks, port scans, Bitcoin mining, all right, activity. So we actually had a customer that was running their Microsoft Exchange servers in AWS. So Exchange servers for email typically run at a high utilization. Okay, they had a couple of employees decided, well, hey, I'm going to install Bitcoin mining software on these servers and hoping that the Exchange activity will cover up my Bitcoin mining activity. As soon as the customer turned on GuardDuty, it detected it right away. They were able to identify where those servers were that had the Bitcoin mining software, uninstall it, and because of the logging capability, they knew exactly who did it when they did it. All right, so they were able to deal with that organizationally. One of the examples I like to use is as soon as you put a web server online, it's going to start getting scanned immediately, right? So Google is going to scan it add it to the search engines. You're going to have Cybercriminal scan it. You're going to have people scanning who are just, it's just a hobby for them, right? So your SOC analyst, your security analyst, how do they know which of those scans are the ones that are more of a threat to your organization, right? So when we add that threat intel that we get coming into GuardDuty, they can start seeing now, okay, well, this one is more of a malicious scan than this scan over here, okay? But in addition to that, it can tell you, okay, well, this is the IP address it's coming from. This IP address is a known cyber criminal, right? This IP address has done bad things on the internet elsewhere. It's coming from this country. Maybe you have concerns about activity like that coming from a particular country or a particular ISP. All right, so now you're starting to get that context coming in. All right, now this is great. It really helps your security analyst, but depending on how much is coming in, your security analyst can still get overwhelmed. Right, even with the alerts, which ones are the ones that they should be looking at? Even if it's only one, it still can take them minutes or hours to do the research, figure out what they want to do, and implement a mitigating action. Right, so this is where automation comes in. You've got to automate your security operations, right? In this example, GuardDuty detected a malicious scan from an IP address that's known to be a cybercriminal. It creates a CloudWatch event. That event triggers an AWS Lambda function. So AWS Lambda is our serverless function service that just has commands or snippets of code ready to execute based off an event. So now you have this event that triggered the Lambda function. The Lambda function is going to take that cybercriminal IP that's been scanning your server and add it to a web application firewall filtering rule, right? So this all happens within a couple of seconds. So now that malicious actor can no longer continue its scan of your server. It cannot try to exploit that server. In addition, it's also not able to scan or exploit any other servers that are behind your WAF, okay? So now, in a matter of seconds, you've remediated this threat, okay? You can have it send alerts. In addition to that, you can have it add it to your firewall, into a Slack channel, add it to your configuration change management database. This is really important. How often are your security operations, the changes that your security operations team actually make it back into your configuration change management database, right? Because they're always going from one thing to the next, right? They don't have time to always go back and update a configuration database. So now you can automate that. So anything that's taken action on is automated. In addition, you can't audit a human behavior, right? You can audit these technical actions. So not only you improving your security operations and mitigating these threats, but everything that you're doing is now auditable, okay? I think the key here is if you have a security operations team, a lot of times what we see is you have your tier 1 analyst, which is somebody who's young, right out of school, super motivated, super intelligent, and as soon as they get hired, they're told, don't touch anything. Here's the playbook. If something happens, just follow the playbook. If you don't understand, if the playbook doesn't answer the question, then call us, right? And so the problem with that is kind of a waste of a human resource, right? In addition, anything that's a playbook can be automated for the most part. And lastly, if you need to, you can add human stop gates, right? If you don't have full confidence in the automation, or you really do need a human to make a judgment decision, which is what we do best, you can add a human stop gate. So you can automate all the preparatory actions and research and give your analyst a choice. Do you want to add it to the WAF? Add it to an ACL? Do you want to ignore it? Then the human can make a judgment decision, click a button. Now, this is not an application. It's something you'd have to build yourself. There's little buttons for your SOC analysts. But then from there, it would go into whatever the actions were that your analyst chose, okay? So you can add in those human stop gates if you need to. All right. So this is just a list of most of our security services. I think one that's not on here is Security Hub. Security Hub starts bringing in their information from GuardDuty, Macy, and other products into one console for you to see everything coming together. A couple things that I want to highlight. We have a saying that says you can move fast and stay secure in AWS, and that is absolutely true. But I'm going to tell you, the one time you need to take some time is in the very beginning to get your governance model down. You need to build your guardrails, right? Build the guardrails so that the development teams, your production teams, your business units can go fast and stay secure because they got the guardrails up. A couple areas that you're going to want to focus on that is your IAM. Focus on your identity and access management as part of your initial governance structure, okay? Focus on your encryption key management as part of your governance structure. Get that right from the beginning. A note for KMS. KMS is FIPS 140-2 validated hardware and compliant, which right now is basically the gold standard for encryption. You can bring your own keys. You can have it generate and manage keys for you. Right? No person inside of AWS has access to those keys. We've had to prove this to every auditor and about every government around. So you can use KMS to help automate your key management and still be able to make sure that you are the only one that has access to your encrypted data. Let's see, how are we doing on time? Okay, got a couple minutes. Organizations will help you manage multiple AWS accounts, right? So you can implement some centralized governance at the top to help you manage your AWS accounts. Cognito, this is something that can be really neat for government providing public services. So now you can use a SAML-based authentication, so your users can use their any type of SAML-based, but say your Amazon.com, your Facebook, your Google, or anything else that you have maybe local that's SAML-based, so they can use something that's maybe from a social media provider that they always know the username and password for, rather than a government website that they may only access once a year and they keep forgetting their username and password, right? We have our own AWS Managed Active Directory, so you don't have to manage your own directory servers. We can manage the Active Directory for you. You just manage the objects you put in. And then, of course, SSO. I've already talked about CloudTrail. I've already talked about, I haven't talked about config. So config really helps you manage the configuration changes within your environment. Right, so anytime something happens, the first question is, well, who changed something, right? When something breaks, who changed something? You can go back and you can look at all the changes that are made in your environment, so you know if you need to roll something back or not, okay? Also, there are config rules. So you can have rules set up so that if you have a rule that said all your S3, all your storage must be encrypted, and somebody creates an S3 bucket that's not encrypted, it will encrypt it for you, all right? I've talked about CloudWatch for collecting all of the logs and alerting. I've talked about guard duty, and I've talked about the VPC. So I've talked about Systems Manager, Shield, WAF, Inspector, and the VPC. I've talked about KMS. Cloud HSM was a precursor to KMS. So if you want a little bit more control over your keys, you can subscribe to Cloud HSM. You're going to want at least 2, right? Because these are physical devices. So if one fails, you don't lose all your keys. So if you want a little bit more capability, Cloud HSM is also FIPS level 3 validated. KMS is FIPS level 2 validated. Okay. I've talked about Amazon Macie. So we also have our certificate manager. So this allows you to generate and manage your SSL, TLS certificates for your encryption in transit. And then, of course, our server-side encryption. All right, so you can encrypt pretty much any type of storage that we have for you, databases, and everything at transit, right? So the key to data protection is encryption, right? That's the big key. I've talked about config rules and Lambda that you can use to automate. And the most important thing for me when I'm talking to customers is make sure your security operations is part of the initial move to the cloud, right? We have a lot of customers that start with your basic websites because they're non-sensitive data. It allows you to kind of learn the environment without taking much risk, all right? And what happens is they'll start moving from this to backups. They'll start moving down the line, and then all of a sudden they'll get to mission-critical applications, and that's when they bring in the security team, right? And then that's when the security team says no, because the security team was not part of this initial journey, right? The security team did not get an opportunity to learn, to train, to figure out how they were going to do their mission in the cloud until the business decided they were ready for something more critical, all right? So my recommendation is make sure security operations is part of your first move to the cloud. Regardless of what that workload is, make sure the security operations are monitoring the logs, they know how to respond to incidents, and they're able to track that and do their job in the cloud. I think this is one of the most powerful quotes. If you look at NASA, the type of people, I mean, we're talking about literal rocket scientists, some of the smartest people in the world that come from all over the world, and they have a pretty good budget. And they felt that they could achieve greater security in AWS than they could do themselves in an on-prem environment. And so with that, my personal journey to the cloud was that, yes, I could achieve all my security objectives and compliance requirements in the cloud, but I could actually vastly improve my security and compliance in AWS. And so with that, actually 30 seconds. If you're a student, AWS Educate, you might hear this often. AWS Educate, free online training, free AWS credits to learn. This is if you're a student at a university. If you're an employer, you can post jobs to the job board here, specifically looking for people that have AWS knowledge and training, okay? And so with that, I really appreciate your time for this presentation, and I think we have 10 minutes for questions. Any questions?